Now in this video, we're going to find the power in each element of this circuit. So the question says, find the power that is absorbed or supplied by the elements. Now we have quite a few elements in this circuit. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to be finding the power of 9 elements. Let's start with element 1, right? We're going to start right here. So we're going to say the power of element 1 equals current times voltage. Now the current in this element is going to be 2 amps because we can see the current is flowing in this direction into the positive terminal. Therefore, we can write this as 2 for the current, and the voltage is going to be 12. So when you solve for this now, the power in element 1 is going to be 24 watts. And we know because it's a positive power that this element is going to be absorbing power. I'm just going to write absorbed. Okay, let's look at element 2. So the power in element 2, I times V. The current going into element 2 is 4 amps, but because it is entering the negative terminal, we're going to treat it as negative. Therefore, we're going to say the current in element 2 is going to be negative 4 multiplied by 6. When you solve for that, you're going to get negative 24 watt. And we know because it's a negative power, this is going to be delivered or supplied. I'm just going to use supplied. Right? Now let's do element 3. We're going to do this element right here. We're going to say the current in element 3 equals current times voltage. The current in element 3 is going to be Ix, which is 2 amps. And because current is flowing from the positive to negative terminal, it's going to be a positive current. So we're going to have 2 amps. And the voltage across this element is 6 volts. So we're just going to have 6. Now when you multiply these two, you're going to get 12 watt absorbed. Alright, let's do element 4. The power in element 4 equals I times V. So let's find the current and let's find the voltage. The current is going to be 4 amps going into the positive terminal, so it's positive 4. And the voltage across this element is 9 volts. So we're going to have 4 times 9. When you solve for this, you're going to get the answer 36 watt, and that's going to be absorbed. Okay, let's do the power in the 5th element. So the current that's entering this 5th element is going to be a positive 2 amps, and the voltage across this element is 24 volts. So we're going to have 2 for the current and 24 for the voltage. So we're going to have 2 times 24. Let's plug it into the equation. When you solve for this, the power across the 5th element is going to be 48 watt absorbed. Okay, now let's look at all of the sources that we have. So let's start with this source right here. So we have a voltage source, and to calculate the power across this voltage source, we're just going to use the formula I times V. We have the power across the 24 volt source equals IV. When we plug in our values, we know the current across this source is going to be 4 amps, but because it's entering the negative terminal, it's going to be negative 4 amps. So we're just going to write negative 4. And we know the voltage is going to be 24 volts. When you multiply these two, you're going to get the answer negative 96 watt. And because it's negative, we know this power is being supplied. Okay. So let's calculate the power of this source. This is a current-dependent voltage source. So we have 3Ix. So the value of this source is dependent on the current Ix. Now let's look at our circuit to see whether they give us the value of Ix or whether we're going to have to calculate it. When we look around this circuit, we see we have the value of Ix, and that's going to be right here. So Ix equals 2 amps. The value of this voltage source is therefore going to be 3 multiplied by Ix, which we know is going to be 2 amps. So we can just say 3 times 2, and that's going to give us 6 volts. So now that we know that this source produces a voltage of 6 volts, and the current that's going to be passing through this particular voltage is going to be 2 amps, but because it's passing through the negative terminal to the positive terminal, it's going to be a negative current. So when we set up our equation, we're going to write this as the power of 3Ix equals IV. We know the current flowing through that source is going to be -2 because it flows through the negative terminal, and the voltage, what we calculated, is going to be 6 volts. So we have 6 for the voltage. When you find the power of this, you're going to get the answer -12 watt, and that's going to be supplied. Okay, we have 2 more to go. Let's do this source. So let's find the power of this current source. We know to find the power of this 6 amp current source, we're first just going to write down the formula. The current in this particular source is going to be 6 amps, and it's a positive 6 because it's flowing from the positive to the negative terminal, and the voltage is 12. So we're going to have 6 multiplied by 12. When we solve for this, we're going to get the answer 72 watt. And this is going to be absorbed. Okay, we have one more source. So we have this 15 volt source. We're going to calculate the power of that. Power 15 volt source equals IV. The current flowing in that source is going to be -4 amps because it flows from the negative terminal to the positive terminal. So we're going to have a -4 amp current multiplied by 15 volts. When you solve for this, you're going to get the answer to be -60 watt, and that's going to be supplied. This is our power for this particular element. Now, let's just confirm that we have the right answers, right? We know if we add up all of the powers, we should get a total sum of 0. So if we say 24 watt, we say 24 watt plus, we have -24 plus 12 watt plus, so we got the 12 from the third element. Now we have plus 36 watt plus, we have 48 watt from the fifth element plus -96 watt from the 24 volt source plus -12 watt from the dependent source. One second, let me just move this over. Plus 72 watt from the 6 amp current source plus negative 60 watt from the 15 volt source, all of that should add up to 0. So when you put 24 minus 24 plus 12 plus 36 plus 48 minus 96 minus 12 plus 72 minus 60 in your calculator, you're going to get 0 equals 0. And this is what we always should get, because the power supplied should always equal to the power absorbed. So this is how you answer a question like this, but you must be able to recognize when elements are in series, and you must also be able to be very comfortable with passive sign convention. If you get the signs wrong, your answer is going to be wrong.